Hello everybody. Put the title here just to make sure everyone's in the right room. I'm Chris London. I will be presenting on refactoring. I don't know if anybody had a chance to go ahead and download the PHP code that we'll be going through. It uses PHPUnit to test the software. That's what the installation is. I don't know if hopefully it worked out for everybody. So my presentation today is mostly going to be centered on Martin Fowler's Refactoring, improving the design of existing code. It's a great book. All the examples are in Java, but it's not too hard to understand. A good list, an explanation of bad code smells. Who here knows what bad code smells are? You go to determine anybody. That's to determine anybody. Basically, a bad code smells when you're looking at something that's just kind of funky to you. You're like, this is wrong. You can't really tell why. We actually have a huge list. I'll pull it up here in a minute, of all the possible things that could be wrong with it. And then after we talked about these bad code smells, we got over 200 pages of refactoring techniques on how to fix these code smells. We got stuff like the move method, the extract method. I might touch on a couple of them, but I might not get to it. So this presentation will contain his point of view about refactoring. So if anybody doesn't like anything I say, you can take it up with him. I'm not here to debate it. And I'm sure some of these things are going to seem pretty far-fetched to some of you. They were pretty off the wall to me. A couple of them were off the wall to me when I first read it, but I'm actually starting to take a shine to it and liking it quite a bit. So here's the first thing: refactoring is not optimization. Does that make sense to everybody? Basically, there are two separate things. As developers, we should all have our different hats. There's one as a developer, so we're adding new features, fixing bugs. And there's one for refactoring and one for optimization. You shouldn't try to have the hats on all at the same time. You should make sure you know what you're doing. Like if you're trying to refactor something, you don't add new features in while you're refactoring. You focus on what you're doing. And you'll switch hats frequently throughout the day, but it's really good to know which hat you're working with at any given time so you can really benefit from what you're trying to do. So refactoring is a process of changing your software so that it doesn't change the way it behaves at all. Every function will still have the same input and output, but the underlying code will be improved, so that's much more readable for the software developers. So refactoring doesn't in any way make the code run faster, doesn't make your code work better. Usually when refactoring, you'll find bugs, and it helps prevent bugs in the future, so it does help. But that's different from optimization. Optimization is when you improve your software for speed and performance. And that should only be done when you're profiling your code. So here's an example of refactored code versus optimized code. It's kind of a silly example. I don't know why anyone would ever do this. But as you can see in the top example, we've got a for loop going through the code. And at the bottom, we have it hard-coded all 5 values. So the bottom code will run faster, and the top code won't. But the top code is much more easy to work with. You know, if your boss comes and now we need to print out their salary, it's much easier to edit the one line than it is to copy and paste 5 more lines for the salary output. There's a little file in that repo for speed test. You can actually run this and see which one's faster. 99.9% of the time, the optimization one is 0.02 of a second faster, running through it 10,000 times each. So here's some rules about optimization from Michael A. Jackson. First rule of program optimization: don't do it. The second rule of program optimization: this is only for experts. Don't do it yet. So I think one of the biggest problems with optimization, and I've seen this growing up through PHP, is you get people that will argue micro-optimizations all the time. I haven't had that too much recently in my junior days. You get people saying, oh, single quotes is faster than double quotes. Oh, if else is faster than ternary operators. But there's no sense in micro-optimizing, trying to shave off millions of milliseconds, unless you're working with some real-time application. So the only time we should really optimize is when we're using a profiler and we see that there is a need somewhere that we need to actually optimize our code. So here are some bullet points on refactoring. It improves the design of the software. It improves how the auditors work together. You can decouple your code. Make it easier to read and to understand. helps you find bugs, helps prevent bugs in the future. And all of this will help you as a developer develop new features faster, which is what everyone's boss wants. I didn't really worry too much about refactoring until most recently in my current job. It's a startup, Genomics, and they were using a purely outsourced company for the first 6 or so months. I don't know if you guys have experience with outsourced companies. I've never had any good experience with outsourced companies. So we ran into some pretty interesting code. Anyone spot the issue with this code?
The backtick?
Yeah, those backticks up there.
Well,
go over
sorry,
to the
that's
other
just putting it in the keynote. Those are okay. That's not it.
Does the same thing.
Yeah. No matter if it passes or it doesn't pass, it's going to set the key to the tilde. So that was actually a bug. So this is setting the command line operator for searching with awk. The tilde is a contains or regex. So all of our greater than or less than searches weren't working because they were being forced to tildes.
Yep.
Here's another one. This one actually didn't cause a bug or anything, but it's pretty useless. At least the first if was pretty useless. So this is more of what I would call a WAP. So here's our list of bad code smells that Martin Fowler likes to share. Some of them are kind of interesting. One I'd like to point out is the comments bad code smell. So usually when you have comments, that's a pretty good indicator that something about the code is too hard to read. Comments, he said, should only explain the why and not the what. So you can have a comment that says, we're doing this way because the compiler does this and it works more efficiently with this. We optimized it. But if you're saying, oh, this section of code will calculate pi to the nth degree, instead it should be a function named calculate pi to the nth degree, just so it's more readable as you're going through. All right, so let's go through this PHP code. Pull it up here. This also comes straight out of Martin Fowler's Refactoring book. I'm going to increase the size of this font here. I don't know how to do that. Maybe I just change the resolution.
It's like Apple Plus, just zoom in on the font. That was just a problem.
Anyone use PHP so I know how to zoom in on the font?
The command plus was doing it.
Control shift or range.
Oh, that's on it.
Range, not control. We're out there, you gotta see everything.
Command plus make the text bigger.
Command plus makes the text bigger.
Let's just do it on mine. It's white text.
PHP store everybody.
There you go. That's better.
I can't see my other.
Better for whom?
All right. Here's one class. Now we get out of presentation.
You might have to escape. Making this F11. Yeah.
Oh, that was a left command for that though. And we have a hold on their computer, I'll use your computer. No.
exit presentation mode. What are the hotkeys on that? You're gonna have to talk over that.
They had command, well, they had full screen mode, which is super like that. And you can see computers working.
All right. So we go ahead. We have our software code over here. This is a simple movie rental application. It goes ahead and keeps track of, well, it doesn't actually keep track of anything, but it can print out users' rental history, like the movies that they've rented, how much they owe, that kind of thing. You can run this by running bin print statement. So we've got Jim Bob in there. He's got a few movies rented. He owes a total of $25 and he's earned 7 frequent rental points. So we open our code. We have the customer class, which holds the customer, their name, all of their rentals that they have, and they have a statement function for generating that statement that we just saw. The movie class is pretty simple. It just has the getters and setters for its values. Rental class is pretty simple. It just has getters and setters for its values. So this example is pretty simple, and it probably doesn't need to be refactored. But it's just an illustration for our purposes. So one question you might ask yourself is, why should we refactor? Isn't it just purely aesthetic? It's just purely to make it look nice for us as developers? And I would say yes, but only until you have to change something. So initially, yes, if I went in here, changed some variable names, there would be no point to it unless I actually had to add a new feature. So my boss comes in and says, hey, we also want to be hip and cool and make this into a website, so let's have an HTML statement as well. I think this book was made in the 90s or something. Now hip and cool would be a mobile app. But so what could we do? I mean, we could just copy and paste this whole giant thing, modify it to include the different HTML tags if we wanted to. And that could even work too, you know, it depends on what the feature plan is. But if you know this is going to be something that you're going to be modifying a lot, and you're going to add, you know, you're going to have to change the pricing structure for these different movie types. That's when you get in trouble with just copying and pasting, because then now you're going to have to remember to go and change this section here, but then also the same section in the HTML statement. So let's go ahead and refactor this. This is probably the only thing in this code that really needs to be refactored. What's the first thing that you guys would do to refactor this?
Anything that has to go too deep, you might want to decide making that another method.
Yeah.
Just because you get so deep, you get lost.
That's a very good thing. Ron, next. Anybody?
Add a flag for the output type,
Add a flag for the output.
so you can specify whether it's plain text or HTML.
Good, not the H I'm looking for. Next.
Is it covered by tests if it is run them?
Well, bam! Yep, the first thing you do before you refactor is test. You shouldn't do any refactoring unless you run tests. So that's the big key, is you can't do any refactoring unless you have tests. Because that way you don't know if you're introducing new bugs or actually fixing things. So luckily for us, we actually do have test cases in the code. They cover everything that we need to cover. And so, like my friend Chris up here was saying, the good thing to do is look for the stuff that's really deeply nested, and we can probably take it out. In this case, the switch statement only is modifying one variable. So we can easily take out this switch statement and make it a new function. So let's go ahead and say public function amount for rental each. Paste it in there. Got to bring in some of our variables we had. now that we refactored that, we go ahead and test unit tests. They still pass. Everything we did was just fine. An important thing about refactoring is variable names. I think variable names are pretty important. I think we should have good variable names because it helps really communicate what the code is doing. This each doesn't help me too much. So let's go ahead and refactor this guy. We'll name it rentals. I think that's helpful. And then this amount. One thing that Martin does a lot in his code is all his functions, they have a return variable, and that returns what the function is going to return. All right, we look at this function and we realize nowhere in this function are we modifying or using any information from the customer. So that's another code smell that this function probably does not belong in the customer function. So it's only using a rental. So we'll go ahead and take this function and move it into the rental class. And then all the places where we have rental become this. That should be good there. We'll go ahead and make this just be return for rental amount for our unit test. It's the work rate. This function right here is probably now pretty useless, so we can go ahead and get rid of that. So we'll just say up here, each amount for, I don't like the name amount for, so let's do get charge. If that makes more sense. It's get charge. Let me go to the unit test again. And they're all working great. So that worked. No issues. So we can go ahead now, if you're following along, you can actually check out step 1. Discard local changes, you know, your code will be up to date with where I was. This is linked on the join, or the joined in page. If you ever want to look at it later for reference. So for the next step, we're going to do another small one. We want to get rid of this frequent renter points because it's very similar to what we were doing with the get charge. So we can take it out, make a function, get frequent renter points. I think it's the rental. And then set this to start out at 0. Return it. So we can say frequent renter points plus equals this get frequent renter points. All right. So having long function names is cumbersome if you aren't using an IDE, but for most IDEs, when you have code completing, I think it's not really a big deal. Make sure code's still working. Oh, messed up. Points. Default's 1. There you go. Okay, so this is the same situation. We're only dealing with the rental object inside here. We're not touching the customer object, so we can go ahead and extract that. Put that also into the rental class. That. Replace that with this. This code can actually be reduced. It's kind of confusing at the moment, but basically what it's doing is, if it's a new release and it's been over 1 day, you get 2 points. Otherwise, you get 1 point. So let's go ahead and make our code say that. Return 1 point. Otherwise, those kind of backwards. I think that's a little bit easier to read. What's that?
The get days rented function, is that available?
Yeah.
Oh, okay.
this is no longer this get rental points, it's each get rental points. Run it, still passes, it's great. So one thing you could also do, if you want to make sure that it's actually, unit tests are actually testing what you think they're testing, you just intentionally change some of these feathers, change the price of a regular, move it to $2,000 a day, and it breaks if the prices don't match what it used to. We can see that unit tests are actually helping us at this moment. All right, now get ready for the ones that you guys are going to call heresy on me for. Martin Fowler hates temporary variables, especially in long methods. But there can come a time where somebody starts using the same name of their variable without realizing that's been being used somewhere else, and it can actually cause problems. So he likes to get rid of every temporary variable, so we're going to go ahead and do that. Actually, we're on our next step now, so we can go ahead and check out step 2. Okay, so we can find all of our temporary variables for rentals, that's one. Cut that out, put that in there. Okay, that looks good. Let's see, this amount, that's a temporary variable. The only way to get rid of that, we'll go ahead and make a new function called get total amount. And what we're going to do is we're going to have to loop through all the rentals again.
So what's the definition of a temporary variable? Is it basically a local variable?
Local variable. Okay. One that you, yeah, local variable.
So yeah, one that you're not passing back or that wasn't passed yet.
And the only ones that he ever uses is like he'll either call it result or return. Basically, when it's what you return from the function. So we're going to go ahead and our result equals 0. Result plus equals.
What was the reasoning behind not having it easier to refactor?
So he said that getting rid of temporary variables makes the code less error prone. Variables can lose meaning after a while. He actually goes, he actually has like a whole section on it, refactoring performance in the book on why he does this with the temporary variables. This is kind of hard for me because it's like, well, now I have to loop through my rentals twice just to get the total amount. It was much simpler just to say this, get the total amount. It's simple just to, the first time I was going through it, to go ahead and just get all the one time. So this also needs to be each get charge. And then we'll want to do the same thing with the frequent renter points. So now we're looping through the rentals 3 times just to go ahead and make this one function work.
Would it be appropriate to do something like make a total of the class variable, and then when you're looping through it, just add the one from the class so that they could class variable. And then
So your return is a class variable. So you still return.
I'm sure I understand.
I would say the only time you would want to set a class variable would be maybe if you're generating a statement class. Like if you have a statement class, that can hold the total. But I don't know if you want your customer to hold the total. Let's see, is that all of the temporary variables? Yeah, I think so. So here we are. We loop through the rentals 3 times. We call this get charge function. We have it in 2 different places. It seems like kind of like duplicate work, but in theory it makes it easier to read and easier to refactor. So now our boss comes to us and wants us to make the HTML statement. We go ahead and copy it, make an HTML statement, and when we can change, start adding tags. I have the tags actually all in the next commit, so I won't add them all here. But by doing it this way, if we change the charging prices or how we calculate frequent renter points, we no longer have to go and change it inside these two functions. It's already there for us. So we can just go ahead and change it where we need to, and we don't have to change code in multiple places. That is also one of the code smells. I think he calls it shotgun coding, shotgun surgery, where you have to make, where you're making one change, it actually has lots of different changes in lots of different places. So we'll check out this next step. Let's take a look. So this is, I would say the customer class is pretty clean now, pretty simple, pretty straightforward. But I think we kind of muddied up the rental class. So one of the things that's kind of, well, we won't get into. So inside this get charge function, we have this switch statement. And switch statements are usually pretty good candidates for polymorphism. And one weird thing about this switch statement is we're actually using the get movie. We're getting the movie, and then we're doing a switch statement on the get movie's information. So that's, maybe that would work in some cases, but in this particular case, the movie shouldn't know anything about, or the rental itself shouldn't know anything about the movie's price codes. It shouldn't care how much the movie costs. All it should be worried about is what movies you're renting and how many days they've been rented. So this get charge function should actually belong in the movie class. So we're going ahead and move that one out of there. So in our rental, we're going to return this get movie get charge. And then in our movie class, this. Oh, yeah. I guess we do need to know the days rented, so we have to have that passed into us. Days rented. Replace these guys. Days rented. And then back in our rental, we're going to pass in number of days rented. So that we can run our unit test. Everything's still working out. So we know that our changes we made didn't break anything. So I can see someone arguing that maybe you wouldn't want to move the cost stuff into the movie, just because we have to know the days rented from the rental anyway. So maybe it could belong in the rental. In this case, it actually works out pretty well for it to be in the movie. And the same thing actually goes for the frequent renter points as well. It's a very similar situation. We go ahead and move that in the movie. Anybody ever feel like when they're typing in front of people that they can't type anymore? Feel like a new beginner or something? So this will go ahead and be this, get movie, get frequent renter points, and we're going to pass in this, get days rented. Check our unit tests. No, I broke it. I'm not returning over. There you go. All right, so I believe we fixed the rental method. It's got everything we need, and it's pretty clean. We fixed the customer method, but now we've muddied up the movie method, movie class. So let's go ahead and check out the next step. Get it put up to date. Make sure it's still working. Good. All right, so now, as I mentioned before, a switch statement is usually a good indicator for polymorphism, and in this case, it might even be good for inheritance. We could easily make a movie class for regular, and a movie class for new release, and a movie class for children's, and they can each take care of their own pricing. which would be pretty good. The only problem in this situation is that movies change their type. New releases eventually get put into regular movies. So instead of destroying a new release object and creating a new regular movie object, we're going to want to use this state pattern or dependency injection conversion. So basically, instead of a movie being a children's movie or a new release movie, the movie is going to contain a price class for it. And so the price class would be either the new release price or the regular price or the children's price. So in this movie class, instead of using a price code, we're going to use a new object called a price. Let's go ahead and create that. So it's going to contain a price. It's going to store it. We're going to get rid of this. And get price. And all of our get price codes are going to change to get price. All of our set price codes are going to change to set price. And then instead of saying this get price code, what we're going to do is we're going to say we're just going to return this price. What do we call it? Get charge. Get charge. So then we're going to need a function in our price class called get price. So now this one we're actually almost developing a new feature. Because we're actually changing the interfaces. So before all the refactoring, all of the functions acted the exact same. They have the same inputs and outputs. We were just adding intermediary pieces. But now we've changed our constructor for the whole movie class. So it's actually a larger change, but I still think it's a valid and necessary one. So in our get price, we actually don't really have one for the global price. So we're going to call this an abstract. So we're going to need the subclasses to go ahead and tell us what their price is. So we're going to make a new class for price new release. We're going to make a new class for price children's. Class price regular, and then these will all extend price. And then we can go back to our movie method and see what each one does. So this is the regular price. So we go with our regular price. Got our new release price here. Does everyone know what the word polymorphism means? Yeah. So basically, we took the one select statement or one switch statement and broke it out into multiple different pieces. So it's usually maintained that way instead of having that switch statement. So it's separated to object-oriented wise, that each price knows how to handle its own price, and there isn't some global class that just knows everybody's price. It's also easy when you do that to add new classes in for new class types. extend. All right, so I think that's everything for price. Makes that much more simple. And then we're going to do the same thing for get frequent renter points. All of them just return one, except for the new release. So we're not going to abstract this one. We're just going to make this its own function. Return one. Then we're going to take this code and we're going to add it for get frequent renter points for the new release price. We don't need it's new release price because we already know it is new release. That should be that. And this one will return this price. Get frequent renter points. All right, so that's all of our code. It's now much more clean, I think. I can't run into unit tests because I changed the constructs. Let's go ahead and fix this real quick. I'll just comment this out for the meantime. This is not how you really fix a unit test.
Error 14 now. Give me errors.
Also, I wouldn't use this as an example of how to run unit tests either. This, in particular, this test statement is more of an integration test as I'm testing how all of these different pieces work together. And I think Sebastian Berkman would probably shoot me for doing this. So instead of doing a movie regular, we're going to say new price regular. Really nice guy. I don't know if you guys ever met Sebastian Berkman. He's the guy that wrote PHPUnit. He comes to SendCon every year.
So when you're refactoring code like that, really what you're concerned about is the integration tests, right? Because the unit tests are going to pretty much break no matter if you change any of the internals.
It depends on what you're changing. If it's just a simple, like if you have the same input and output of a function, the unit test isn't going to break. But usually unit tests, you don't want to test the external function, so once you did break the piece out, that unit test is kind of useless as a unit test. It turned itself into an integration test because now you're testing the two different methods. There are mock objects and stuff to be able to actually unit test, but that just means that every time you go and modify a function, you're going to have to modify your unit tests. So I didn't get it to work. I'm going to cheat and just check out the next section of code. And wow, magically my movie test one got uncommented and fixed, and my rental test got uncommented and fixed. And my unit test passed. Yay! Okay, so after all that, we've really broken up our pieces. You know, I don't think we really have any function in here. Pull my actual code, not the test. I don't think we really have any function in any of these methods that's more than 3 or 4 lines of code. My boss hates this because he has to like drill down tons of times to be able to get stuff. There's some more functions we can break. But I really think that if you have the right tools, it's not that big of a deal. Lots of IDEs, I can just point at my method and point to it. It will take me there. Hopefully you guys know all those tips and tricks are pretty useful. So that's what I have on refactoring. Do you have any questions? Anybody going to take anything away from this or just be like, that guy was nuts?
I don't know if you're familiar with like on the Ruby world, but like the app code climbing.
What's that?
It's basically like they analyze your code, like find good candidates for refactoring. I know such like service exists in the PHP.
There's lots of, there's like code, there's PHP mess detector, and PHP code sniffer. that will rate your code, tell you about functions and stuff about there.
What would you say is the most important reason to do this?
Basically to make our lives easier in the future. Usually I probably wouldn't refactor unless I came to the point where I had to add a new feature. So if the code's working, if it ain't broke, don't fix it, until you have to go change it. So basically your workflow would be get a new feature, add unit test, refactor, and then actually work on that new feature. Unless the code was already worked out well for you to add a new feature without it being an issue. Because that's the thing is, if the code is hard to work with, then trying to add a new feature is going to be a nightmare. You're going to introduce a bug that broke some other piece somewhere else you didn't even know. So it's mostly for our sanity. So a lot of the times I would say, if it works for you and it works for your team, go with it. You don't have to follow Martin's letter.
What bad smell has been most useful for you to get rid of?
Long method, I think, is the worst one for me. Probably still is the worst one for me. We actually had some methods, single methods that were over 1,000 lines, and so it was just a nightmare to try. We had like huge, 500-line if statements, like if, and then the else wasn't for 500 lines down, and there's another 500-line block, and so we really had to break those out because it was difficult to try and figure out where the bugs were and add new features to it. Well, that's all I have. Thank you.